Hello, hello. I'm going to do my quick self-check about all my streams, make sure everything's working. If you're here and you hear my voice and you see my face, first, I'm sorry. Second, would you let me know in chat that you hear me okay? Looks like I'm live on YouTube. Looks like I'm live on LinkedIn. I think I'm good to go. Awesome. I think I'm going to have a small crowd today. I announced this one late. Small crowd meaning like not a crowd. I think just a few people. But I'm going to code anyway because I like coding and I don't need people to watch me while I code. I can code by myself too. So if there's nobody here, no problem. If you're new to this stream or you're watching the replay or whatever, if this is your first time, I want to let you know I also do a daily email list on the topic of Go. Right now I'm going through the Go specification, breaking it down into easy to understand chunks and explaining that, trying to help make it less intimidating for people. So if that sounds interesting, head over to boldlygo.tech/daily. You can sign up there for that mailing list. I also announce these live streams and other events and blog posts and stuff on that email list too. Today I'm going to be, I'm working on a tool to simplify Go code. It's kind of like a linter or static analysis tool, except it actually rewrites the code too. And it's using some standard tools that come, libraries and stuff that come from the Go team. But I'm trying to add some of my own features to this tool I'm building. And I'm going to do that today. I'm going to add a feature, hopefully. If everything goes well, we'll add a complete feature to that project today. Let me share my screen. So I'm going to start with a little demonstration of the code, of an example of the code I want to rewrite and what it should look like. Oops. So I'm wanting to take advantage of a new feature that was added in Go 122 called slices.concat. But let me pull up my editor. I'll show you what I want to do. So let's imagine you have some code that looks like, I don't know. Doesn't really matter. The point is we have multiple slices and we want to join them together. Before Go 122, you had a couple options. You could do something like this. I might do S1, S2. You could do that. If you wanted to try to get clever, you could try to merge these together. You could say something like, you could do that. It's kind of ugly. And if you have a lot of these, it gets really ugly. With Go 122, we have a new option. We can do this. We can just do that. And we get the concatenation of all three of those together. So my goal today is to write a feature that will detect either of these patterns and convert them to this for me. That's my goal, okay? Not only is it easier to read and shorter, it's actually should be faster in many cases. Not all cases, but in many cases it can be faster because it saves some allocations into the hood. So I hope that makes sense, what I'm hoping to accomplish today. I'm going to close this editor now and get started. So the project I'm working on, if you watched last week, you'll recall it was called Denude. I need to change that name, but that's what it's called right now. So I'm going to pull up that project. Zoom in a little bit. It's probably hard to see. It's hard for me to see. It's probably even harder for you to see. All right. Put my editor here. What should I call this feature? How about slice concat? All righty. Now, before I get started, what I'm going to do is copy one of the other features I have, one of the other analyzers, and then I'll duplicate that, and then I'll go ahead and modify it. So let's start with that. I don't really have any that are very similar, so it doesn't really matter which one I copy. I just want the boilerplate. Sterling, why not? All right, let me pull up this, and I'll make the changes to the package name. I'm not really completely happy with the organization of this project, but I don't care that much right now because I kind of see this as a learning project. Although I am testing it and I want it to work well. I'm trying. I want to learn how ASTs work and all that stuff with Go. So this is largely. I mean, although I'm using it, and I've actually been using this to rewrite a code base for a client I'm on. Another goal of this project is just to learn how these libraries work, and then I intend to redo this with a different structure, a different format. So normally when I see myself copying and pasting boilerplate, that's a sign that I should be restructuring. And I see that this is a sign I should be restructuring, but I'm intentionally not doing that yet. So just to be clear, I don't necessarily recommend this as good practice, but since this is still half a learning project, I think it's okay in this case. So what does this one do? This replaces multiple append calls with a single slices.concat call. All right, now here's the logic for my one I just copied. I'm going to delete all the internal logic. So this last bit here is what triggers the replacement. I'm going to comment that out for now. So I'm going to uncomment that part after I add my own logic. And I'm going to update this. Run to be accurate for this one. Use of, no, not string literals. Multiple append calls in sequence. All right, and then I'm going to make a to-do list with some examples here. So the first one, no, I don't want that. Stop it. I want it to be something like append, and append. I want to replace that with slice. Okay, yeah. So there's one example. I'll come up with others. I'm going to start with that. Hey, how's it going there? Thanks for joining the live stream today. Just saw a comment asked how goes it? It goes. How can I answer that? It goes well. That's boring. Well, it goes. How about that? Well, it goes. There we go. All right. Let me finish the boilerplate here. So go ahead and add that to my get working copy. Then I need to edit main.go, where I tell it the new analyzer. What was it called? Slice concat. Was that right? Or was it slices concat? Slice concat. And it's not detecting it here, so let me just do it the old-fashioned way. Let's go concat. There we go. All right, main.go is updated. And then the tests. So we have this directory full of tests. I talked about this a little bit last week. I'll go over it again. These are txtar files, so text archive files. The idea behind a txtar is that it's a human readable archive file. So it's like tar, but you can read it. So it doesn't have like data validation and checksums and stuff, but it's really simple for things like this. So at the top here, above the first double dash, I have my test definition, which is using a tool that comes from Go. Basically, I execute this command, and then I can do some tests on it. Does it have this in standard error output? And then I do a CMP to check that the output it generated matches what I expect. So I need to update this command to use the new rule I'm creating, which was called slice concat. And then here is foo.go. This is the input file. You can see that's referenced here and also here. So this is the input file, which has the version of whatever code I want to be rewritten. And then foo.go.golden down at the bottom right here is the version that I want it to be rewritten to. And so if the output differs from the expected output, I'll get an error in my test. So let's make up an example here. Let's say, I'll just basically redo the example I created before. Let's do s1 colon equals int 1, 2, 3. s2 colon equals 4, 5, 6, and s3 7, 8, 9. And then I'm going to have, no, here I don't need to assign to anything. Actually, I'm going to use a blank variable. Because I probably want to have multiple copies of this, different variations, and make sure that I check them all correctly. And I don't want to have to create new variable names for each one. Plus, the compiler is going to complain if I don't use that. So by doing underscore equals, I'm saying do the calculation, but discard the result. So that's good enough for my purposes here. Actually, no, you know what? It's not good enough for my purposes here because I actually need the result because I need to append to that result. So I'm going to put it in a code block. No, I'm not going to do that right now. I'll just do I'll do R for sending for result. Why did I just spell it out? S1, S2, dot, dot, dot. Result equals append result S3, dot, dot, dot. Okay, so there's my first case. Let me copy this down now, and then I'll do the rewritten version, which should look like slices.concat S1, S2, S3. And it needs to add import slices. So that's what I want the output to look like, right? Now, if we run the test, it should fail. Oh, I'm in the wrong directory. Let's try that again. So it does fail. For one thing, it stops at the first failure. And the first failure here is that the standard error doesn't contain the expected output. I expected it to give me this output, and it did not. We'll fix that. I'm going to move this over to the right-hand side so I can keep that sort of in mind while I'm working. And then over here, we're going to get started. There's so many good Go puns. I have a comment here. How goes it wasn't intended to be a Go pun. There's so many Go puns. I could go all day. All right. So you may recall if you've watched this before, I have a little online tool I like to use to make this job easier. This Go AST viewer. I'm going to use that here. So what I'm going to do is I'm going to paste this sample code, the input, into that. And that will give me a breakdown of what this looks like in AST format, AST abstract syntax tree. So this is what the code looks like in AST format. And this is, of course, the level of stuff we are manipulating when we're going through this and rewriting the code. I'm going to zoom in a little bit. I can't even read that here. So the parts we're looking for, what we're looking for right now is what does this part look like, this append bit. So I know that this is going to be an assignment statement of some sort. I'm pretty sure. So what I think I'm going to do is look for an assignment where the right-hand side is an append call. Let's see if that's exactly right. Here, assignment statement, yes. And then in the assignment, we have LHS, or left-hand side. That's on the left-hand side of the equal sign. And then RHS was on the right-hand side of the equal sign. On the left-hand side, we have this thing called an object called S3. Okay, so we're actually, I'm not far enough yet. I'm looking at this line. Let me go down a little farther, but it should be the same concept. Here it is. So here we have assignment. The first is an identifier called result that references an object called result. That doesn't matter just yet. Here you can see the operator is the colon equals, or the assignment operator, or the declaration operator, I think is what it's called. And here we see that the right-hand side, RHS, is a call expression where it calls a function called append. So that's what we're looking for. So let's start by doing that. So the way this inspect works is it goes through every node of the file and passes it to this function twice, actually, but that doesn't matter right now. So we want to see if we have a node that is an assignment statement, then we might want to examine a closer. If it's not an assignment statement, we'll just skip it, right? And we tell it to return, we return true, which tells it to keep parsing the tree. If we say return false, that means we know that everything at this node and lower is irrelevant. You can stop parsing, but we're not doing that right now. So let's do assignment. And if we don't get an assignment, so this is doing a type assertion. So a node is a fairly generic type. It's an interface called node, which represents all node types. Here we check to see, is it the specific node type? And if it is, or first, if it's not, then we early return from the function, and it will go on to the next node in the tree. If it is, then we continue and do some further inspection. Now, I think probably the easiest next step. Well, so there's two different ways I can go. Trying to think. I suppose so. The two different ways I could go. One is I could see if the left-hand side is a slice type. I can do that first. I think I won't do that though, and I'll explain why. The other thing I do is I go to the right-hand side and see if it is a call, and if so, if it's a call to append. The reason I won't check if the left-hand side is a slice first is because if this is append, that implies the left-hand side is a slice anyway. And further, there are lots of cases where I would have a slice that don't have an append, and I have to do that check anyway. So I might as well do the check I know I have to do, which implies the answer to the first one anyway. I can just skip that first check. So I'm going to add a comment and see if it makes Copilot smart enough here. Check if RHS is an append call. So this is good. So first off, it does not. Let me show what I was doing, and I may care about improving this later, but for now it's fine. It checks to see if there's more than one argument on the right-hand side. Now, usually there's only one, but you can have more than one. Let me just demonstrate what that looks like. You can do this and go. You can do something like that, and you can assign x comma y equals 3 comma 4, which says that x equals 3 and y equals 4. If you do this, then you have two items on the left-hand side and two on the right-hand side, which could potentially matter for this sort of transform. But that's sort of more advanced and it's less likely to matter. So I'm not going to worry about it right now. I want to get this working simply first. Maybe later I'll care about that. So for now, I'm just going to check if there's more than one thing on the right-hand side, return true and keep going. And I'm not going to do a rewrite. I could do the same check for LHS. In theory, they should always be identical. I can't imagine a time when they wouldn't be, except for a syntax error. But by the time this function is called, I already know there aren't any syntax errors. How am I liking Copilot? It does make me faster, especially for stuff like this where there's a lot of typing. You know, typing these big, long, type assertions and stuff can be kind of annoying. I don't trust it to make the right decision. It makes a lot of stupid mistakes, but it does help me type faster. So, if it can fill in something and then I read it closely to make sure it typed the right thing, then that's nice. So it's nice in that regard. Or if you're doing a monotonous refactor, maybe adding a field to a whole bunch of objects that are similar or something like that, it gets pretty good. Once you do 2 or 3, it recognizes the pattern and it helps you do those faster. Pardon me, I need to sneeze. All right, I'm back. Sorry about that. All right. All right. So now we've limited it now to an assignment statement that has a single variable being assigned. That's going to, of course, eliminate the vast majority of our code, but not enough to be useful yet. So we need to keep narrowing this down until we know what we have. And now that I have that, I can actually this didn't actually finish. Let's see if Copilot can keep going, or if I need to give them more hints. It's not doing anything. Wake up, Copilot. Tell me something. There we go. I didn't move that hint. That's all right. So now we have, now it's checking if the right-hand side is a call statement or a call expression. That means it's calling a function, or at least a call expression. Call expressions don't always call functions. They can also be, let me just demonstrate. That is a call expression, but int isn't actually a function, it's a type conversion. But as far as the AST is concerned, it's still a call expression. So that's what we're looking for, is something that looks like a call expression. And then we want to check if, okay, I don't want to, it thinks I have this internal function called it's append call, but I don't. Let me look back at this AS2 viewer. I'm looking for, okay, if call dot fun, I don't think call dot fun can be nil, but maybe it can. I'm actually going to pull up this. We have fun. It's an expression. Okay, I need to do a type assertion apparently. Why though? Why is that necessary? Func ident. There we go. All right, so a couple of questions here in chat. So let me take a break here and answer those. First is hi. My answer is hi. Can you suggest a good book to learn Go with good examples? I have a whole series about this on my YouTube channel. Let me just find the link. The best book to learn Go in 2023. Share a link in the chat here for you. Let me just find the direct link to the video. I did like 13 book reviews last year. I am intending to update the list. There's a few things that have changed this year, but for the most part, last year's list is still great. So yeah, I just encourage you to watch that video. Here it is. So have a look at that video. The main video I recommend is in that video is Learning Go by John Bodner. There's a new edition that just came out in February. So that would be my main update, is get the new version, the new edition. But that's it. Yeah, check that out. Another person asked, I missed the beginning, what are you trying to do here? So I'm trying to write a Go AST static analysis tool that will rewrite code that looks like this to look like this. Basically, Go 1.22 added this new capability, this new feature that lets you merge multiple slices together in a single call rather than calling append multiple times. So I'm trying to write a tool. I'm adding a feature to my tool that will rewrite the old version to the new version for me. Now, I just remembered as I was describing that, I need to add a guard here. I need to make sure this only updates Go 122 code. I probably want to do that today. I know how to do that because I did that. I've already done one feature that required Go 122, but it's kind of a sidetrack. So if we have time, I might do that today, but I'm going to add a to-do note to remind myself. So I add that to my to-do list there. All right, let's get back to this. We're trying to identify if we have this pattern in our code. So I now have a func ident. That's the identifier for the function being called in a call expression. Now I can check if that equals append. And if it does not equal append, I can just return true. All right, now what I'm going to do is I'm going to do something a little bit silly here. I'm going to put possible match, and then I'm going to dump out the code that we're analyzing, the node of the code we're analyzing. So now if I run this test, I should have a little bit of output. Still not going to work. But yeah, I have, so both of these lines match the pattern, which is exactly what I would expect, right? Now my to-do, I'm gonna change what I'm doing a little bit here. I'm gonna start with this format because this is easier to detect. So let me rewrite this to match that, where we have just append, call, append. Oh, I need to change this to a colon equals. I definitely want to do both in the long run, but this one's easier to detect first. So I'm starting with that. Why is it failing? So declared in that use. Oh yeah, because let me do it like this. This assigns the value of results to nothing, which is just a way to get this to shut the compiler up about this error result declared in not used. That's all that does. All right, so now it's just possible match in this one. Good. I have a comment here. Started learning in December and was building a CLI app using Cobra. Was able to do it successfully, but now want to add OCP client facing challenges. Yeah, I mean, I don't know what the challenges are, so it's hard for me to address them specifically. And then the second comment, maybe I need more practice. You can never have too much practice. It's always great to do practice. But if you have a specific question, let me know. Maybe it's something I can help with. I don't know. Yeah, I wish you the best of luck, and I definitely encourage more practice for everybody. Okay. So for this particular pattern, what I care about is, do we have append calling append? So I'm going to do a very naive version of that. Just to start with, I'm going to get better. But to start with, I'm going to be as naive as possible and just make it work and detect the specific patterns. So what I'm going to do is see if the first argument to the append call is another append call. I don't care about this is asking if Copilot wants to check that the number of arguments is 2. I don't care about that. Yeah, I don't care about that. So that's not what I want. I'm going to make Copilot happy just to get it to shut up, though, and delete that. That's the actual thing I care about right there. All right, so now we're checking if I have append and the interior version argument is not append, then I continue going. So if I run this, well, first is going to complain about that. So let me assign that to something just to shut up the compiler. We should have the same output. Yeah, we do. It's still considering this. So now it's looked at this. We have append, and the first argument is a call expression is all it's checked so far. So this could be a different function. So let's keep going. All right, there. Now we've checked that the inner function that's being called is also append, and that works. Okay, now I think we're ready to do that transform. So I want to, I'm going to uncomment this whole bit here. And no, I have to create this report that tells the tool, the static analysis tool, which text in the source code to change and why. I'm going to start with the easy part and rewrite this description because that's the one that I copied from the boilerplate. Combine multiple append calls using string slices.concat. And then I have %s and this arrow %s. This tells it, this just prints out the old and the new code. Now that's just defined up here. I need to define this old and new code. So the old is going to be assignment. And then I'm actually going to modify this, but I'm going to start with this. So this POS and end tell, those are the end positions in the file, like the byte number in the file essentially, where the statement begins and ends. And then I need to give it the new text. This tells it what to replace it with, right? So I haven't created that yet. So that's the next step. And the truth is I am doing this kind of wrong because what I'm doing here, let me show you what I'm doing. I'll just do it right here. I'm going to comment this out again. Close this part out. All right, let me run this code and I'll show you what it's going to do. So it's suggesting that I replace this with something I have to create so far. The truth is I don't need to replace all of that. What I really need to replace is just this part, right? I can leave the result colon equals. So I need to modify this a little bit. So it's not the assignment per se that I want to change. It is the right-hand side of the assignment that I want to change. So let's see if I can just plug that in here instead. It doesn't like that. So I'm not, this is why I'm doing this, to learn this stuff, right? I don't actually know what I want to do here. This particular function I'm using doesn't want a slice of nodes, it wants a single node. Let me see if I can, this underlying one, is it here? It wants a single node also. So I'm gonna cheat here. I'm going to leave it as is for the moment. Okay. Even though it's going to replace more than I need, I'm going to tell it to replace this whole thing with whatever I come up with, which means it's replacing this results colon equals, even though it's not necessary. Pardon me. I'll get back to that though. You might think that's harmless, and in many cases it would be. However, the truth is I'm being more specific than I need to be right now when I look for an assignment, because I could have this append as a direct argument to a function, for example, and then this wouldn't be an assignment. And I want to detect that also, but I'll get there. So for now, I'm going to leave it like it is. If I could change dumper to be variadic, but the function it depends on, this fprintf, is not variadic. So that wouldn't actually help. That's what I was looking at here. This takes a single argument here. So yes, I have a comment on LinkedIn that I could change my dumper to be variadic, and that's what I was just examining. That wouldn't solve this problem. I also have a comment. I've learned the basics of Go concurrency, but I still don't feel completely comfortable with the topic. What recommendations do you have for further improving my understanding? Practice. Concurrency is one of those things in Go that it gets a lot of attention. But one of the reasons it Go is so magical is because it lets you ignore a lot of that. You don't actually have to care about that in most cases. So, but that's not to say that you shouldn't learn it. You should learn it. Practice is the best way, I know. If you don't have a problem in mind that requires concurrency, come up with a toy problem, a worker pool or something like that. I actually talked about that a little bit last week too. I gave a recommendation on that, so you could go watch the replay of last week's live stream where I talked about that a little bit. Yeah, so the follow-up to making this variadic is just loop over those. I could do that. The problem with that is I don't know how those different arguments necessarily. I mean, I don't want to have to reinvent that logic. So in this case, I know that the list of nodes are arguments to a function, and that means that they get separated by commas. But that's not always the case. Depending on the context of that list of nodes, it could be separated by new lines or different things like that. And this printer.fprint knows all of that. And there's probably a way that this set of libraries is designed to handle this. But I don't want to have to reinvent all that logic especially because I might break it, or I might do it wrong, or I might do it right in a way that is broken by a future version of Go or something like that. So I probably need to spend some time better understanding some of those tools. For now, I'm going to punt, and I'm going to solve that problem later. Because right now, for the problem facing me, replacing this, it's not a problem to rewrite the result : equals bit also. So that's what I'm going to go for right now. And then I'll fix it. I'll figure out a way to fix it later when I care about the other use cases. All right, so let's see here. Actually, you know what? I just thought of the solution. The solution is I don't care about RHS. I don't care about that because there's only one of those. What I care about is this. So it's this call that I want to replace. So I put that here. Now I have the text I want to replace, right? Because it's only a single call. That is correct. And now actually I can probably get rid of some of this. Because actually now I don't care about the assignment bit or the RHS bit. Yeah, I'm going to simplify this. If I do it like this, it should also work for the case where this is passed as an argument to a function. And I'll add a test to verify that later, but I think that's going to work. And it's still detecting the right text. So we're good. We're good so far. And I just simplified my code. All right. So now I still need to come up with a replacement, right? So I have this, and I want to construct this. So let's do it. Replacement. I'm going to do that right here. It's still a call expression. However, now I need it to be, fun is going to be ast.selector expression, right? Okay. Oops. And this is going to pull in some complexity, but we'll get there one thing at a time. Slices is the name of the package, and concat is the name of the function. So far, Copilot's on track. And then the arguments. Okay. So the arguments, I need to take the arguments from this is going to be tricky, I think. For now, it's fairly simple, but I'm thinking of corner cases. I need to take the arguments from the inner append first, and then the outer append. So the inner append is from inner call. Let's make this an expression. Okay, inner call args 0, 1, and then call args. Okay, that's actually probably correct for kind of accidental reasons. But let's see. And this assignment should be renamed to call. So that's all I'm replacing now. This might work. quite. Okay, it failed because this text doesn't match. Let's change that. It doesn't need to be an exact match. It's a regular expression match. So I just need to contain the right part of the string. All right. So it actually did this part right. It rewrote that correctly. The thing that's missing is this imports. All right. So I'm going to create a commit here. All right, now I've done this in another one of these tools. So I'm going to copy some logic from there to handle the insertion of the package. It's a little bit complicated though, because first thing I need to do is to see if that import is already in the package. Let me walk through what I need to do, because I'm going to copy things from another package, which is probably going to not be really easy to follow. So I'll explain what I'm doing first. So logically, I first need to see if slices is already being imported. And if it is, I don't need to add the import, right? So that if it's already being imported, I can just use it. If it's not being imported, then I need to make a note that I need to add that import, and then I need to add it. That's complicated by the fact that the import could exist with a different name. So like somebody could have done this. And if they've already done that, I want to use the existing name rather than importing it again. Further, they could have imported something else as slices. You know, they might have github.com/foo/slice or whatever and call that slices. And if they've done that, then I need to import the proper slices with its own name, with a new name. So I would add something like import slices to slices. So I need to handle all those cases. And I need to do that in a way that I can know if I need to import the slices package, and if so, under what name. And then if I need to use a different name, put that name here, et cetera, et cetera. So I've already handled that logic in a different thing, and I'm going to pull it up here to copy, but it's that logic. Now, that particular case was more complex because I also, in some cases, removed imports, which I'm not doing here. Where was that? That was in Sprint. So I'm going to try to walk you through how this works while copying only the relevant bits and trying not to bore everybody. So the first thing I do is I have a list of concerned imports. These are the imports that I might care about, so I don't have to track all of them, right? And this dot import. If you're familiar with dry and wet, I'm making my code wet right now. I'm adding duplication that I will later probably dry up. So I'm going to copy this stuff shamelessly for the moment, knowing that it's kind of silly to do that. And then later I will worry about abstracting away the duplication. So in this particular package, the one I'm copying from, I cared about FMT errors and strconf. In this case, I only care about slices. So I'm just going to put that one in the list and delete the other two. What this is used for is as I read through the package, I look for any uses of this package and I increment a counter. That's basically what it's for. And I don't want to do that for all of the packages that might be mentioned because I only care about this one. Now I have this analyzer type. I need to add the... So I have these 4 maps. I don't know if I need all of them in this case. I don't actually need the import uses one. I just need the import uses is used. That's where I increment. I don't need to increment in this case because I'm never deleting. The reason I needed to track that here is if I deleted the last reference to FMT, I needed to know to remove that import. That will never happen in this rule. So I can skip that. Just to copy these 3. Add them here. So what they do is, as I go through, we'll do this next. As I go through the package, as I'm reading it, I look for import statements, and then I update these 2 maps. The first one is a map of alias to path. So that would be, an example would be Well, here, slices, the alias is implied as slices, so it would be slices to slices. If I had import SL slices, it would be SL to slices, and so on and so forth. And the other one, path to alias, is a map to a slice of strings, and that's the reverse. That takes the path, slices, and maps it to its alias. The reason that's a slice of strings is you can import a single package more than once with multiple aliases. So that's what that would be. All right. And then added imports is a map of the imports that I have added. Now, in this particular case, there'd only ever be one. So this might contain slices. And then it's a path to an alias. So this would be the path slices. And then whatever alias I come up with so that it's not a duplicate of an existing one, which we'll get to in a moment. Hope that makes sense. Let's move on. So here I have this thing called isInterestingCall. That's not relevant to me. Okay. I think I'm going to jump to the bottom of the file here where I start the loop. That's where I need to go next, I think. So I need to rearrange this a little bit. Here, as it stands in this in my new rule, I've created this single analyzer function, and I call it, and I use it multiple times for each file. I need to change that because imports are done per file. So I'm going to move this into this loop down here, just like I did on this side. And then I'm going to instantiate those new fields I just added with empty maps. So I'm going to just copy this bit. So now each instance of this analyzer is tied to a specific file. So for each time I start reading a new file, I start over again counting imports. That's what that does. Now over here, I added three new inspection passes to mimic this. So as it stands right now, I just go through the AST once, and that's it. I'm going to change that. I think actually I don't think I need inspect imports here. Let me see what this does. Should have added some GoDoc for myself. Yeah, okay. So this I don't care about this. I'm going to add GoDoc right now. So I don't need this one for this new test. What this does is it just sets the counter for each import, but I don't need that because I'm not deleting imports. So you can skip that. And rather, the thing I do care about is in this main inspect function, or at the top. I think it's here. Actually, I might be wrong here. Where? I might be misremembering. Let me see where I did that. I want to see where this is modified. It's under increment import uses, which I don't actually. I might have just said everything I just said backwards. Maybe that other one is the one I want. No, that's not right. I'm sure this is what I want. Just wondering. So this is just doing two things, is what it's doing. Let's use kind of an import alias. Give a node, and also it also tracks that. So that tracking is all I care about. And I can do that in my existing inspection thing. So I have this shared function called import info. So what this does is if actually I don't know if I want to copy this. If it's an import spec, yeah, I don't want this one. I want to copy part of it, but not the whole thing. So basically what I want to do is if node is an import spec, then handle something properly. Okay, let me look back at my AST tree here. I'm going to create an import spec so I can just examine what that looks like. Import slices. So yeah, import spec. This is what I'm looking for right here. Let me add another one with an alias just for comparison's sake. Slices. And okay, here's one of the alias. And there's the normal one. And they're both import specs, right? Yes, okay. If import spec, okay. So I want to do this special little logic here. If it's an import spec, then I handle this logic. And then I can return false in this case. I don't need to continue. It doesn't matter because an import spec doesn't have children nodes really, or not of substance. Yeah, so here I want alias. No, that's not what I want. Well, that could work. It might be the best way to go. Let's see, import spec. I'm just going to do it myself for now. Path, okay, equals. I wonder if there's always a basic lit. Let me check here. I think it has to be, but it doesn't say that it is. No, it is always a basic lit. Okay. So path is equal to imports. No. Import spec dot path dot value. Is that right? Yes. Except I need to unquote it. So it's actually quoted. This is the literal version in the source code. So it'll be like quote slices end quote. This will unquote it. I'm going to ignore the error because I know that that's already been handled. So there's my path. And if slices.contains concerned imports path. So only if it's one of the paths I care about, which would be this list. So if it's slices, in other words, then I will continue my processing. In that case, I want to look up the alias. I don't think that's right. The alias will be, so I'm going to actually set the alias to be file path.base path first, and then if the alias is set, I'll set it to something else. So let me explain what that does. File path.base removes everything except what comes after the last slash. Now, in this particular case with slices, I don't care. There is no slash, but this is the general solution to this problem. So if I had encoding slash JSON, it would return JSON, which would be the default alias for the path, right? So that's why I'm doing that. Now, looking back at my tree over here, I need to see if name is nil or not. If import spec.name is not equal nil, then we do that. There we go. So now I have my alias and my path, so I can add them here. So I add the alias to path listing or association to alias to path, and then I add the path, and I add the alias, because remember, there could be more than one alias to the same path for the reverse. So now that is updated. All right. Now this dot import I'm not using yet. I should use that because the thing is that this alias could be a dot. If you're not familiar with dot imports, you could do this. And you can have multiple dot imports. And those don't conflict with each other. So I need to change that here. If alias equals dot import, alias equals dot import plus it's not very efficient, but that's what that does. That should work. So if I have this, if I have dot slices, then in my map I call it dot slices. Period slices as a single word to disambiguate. So I don't treat these both as the same alias. And then if I have, I don't think I've considered this in the other case, if I have it's blank, I should just skip it, right? Because you can have a blank import, which just runs an initialization in that package. Now there's an open question whether if I have a blank import of slices, if I should rename it to slices or not. I'm not going to. For one thing, I can't think of a reason you'd ever blank import slices. I don't think it does anything. And second, I feel I have to think about it a while before I'd be willing to do that in general, because that could introduce some subtleties. Like suppose there was a reason to import slices like that, and so then I renamed that to slices, and then later someone deleted the thing I just did, then that slices would be deleted, and they might not realize it. Yeah, so the comment is you have to look for the situation where slices is not in the imports and add it. That's exactly what I'm doing right now. Yeah, exactly. All right, so we're updating this path. Oh, I need to add the blank import case. I just want to ignore that for now. And if that's the case, then we'll just add a duplicate import. So I'll do it here. If alias does not equal blank, then we do this part. This is a lot of nested ifs. I don't like that. I would refactor this. I don't like this as well. It's way too deep. I think my linter's complaining. Yeah, too many nested ifs. Something to fix. But right now, make it work right. Then I'll make it pretty and clean and fast and whatever else. Alrighty. Where am I? I just clicked something wrong. Oh. Okay, so let's see. Where are we now? So I should have a list now. After we go through the AST, we should have a list of occurrences of slices in these maps. So now I can add the next function, which is to add an import. I'll probably just copy that. So here I have this add import function. I'm not going to copy it directly. I'm actually going to move this into a shared library because I have a pretty good idea. I want to use the exact same function, but I want to look at it first. So it adds import imp. So I call add import with a path name. So in this case, I'll call it with slices, and it updates the analyzer. Oh, I can't move that to my shared library, shared function just yet. I'll have to reorganize this to make that work. So I am going to copy this wholesale. The thing is, it's a method that actually modifies the receiver, and this receiver is defined in each package. So I need to refactor that. But for now, I'm just going to copy this. It's a big copy. What is that? 100 line 196. It's a 50-line function. It's kind of ugly, but that's where we are. So I'm going to copy that function, and then I'll go through it. So it decides what the default alias should be by looking at path. So like I said, I pass in the path I want to import. In this case, it's just slices, but it could be encoding JSON or whatever. So it finds the default alias, which will be slices. Then it looks to see if I have something already defined for that alias in my alias to path map? And if so, and it matches the path, that means I've already imported the right thing. Nothing to do. I can just return that alias. The default alias is good. If not, I continue. Now here I range over the list of aliases registered to that path, right? So here I'm looking up slices to see how many things. So I might have SL, I might have dot, etc. And I ignore the dot import for now because I think dot imports are evil. You should never use them. I wish they didn't exist. And I certainly don't want to make them worse. So I'm not going to use the dot import even if it's there. So in that case, I just continue. If it's not a dot import, then I will return it. So I return basically the first alias. So let me give an example. If I have, suppose my import looks like this. But suppose I have that. I have slices imported 3 times. I'll ignore the dot import, and then I'll return the first one that's not a dot import. So this would be called sl.concat. Okay. So that's assuming I already have it, but it's not the standard name. Then this will return something. If that doesn't match anything because it's not imported at all, then I need to add it. So then I add to this added imports map the path I want to add. No, sorry. Then I check to see if I've already added it. So up here I'm checking what was already in the file. Here I'm checking if I've already added it. So this would be a case where I have multiple instances of this being replaced. I've already handled one of them, and as a result, I've inserted an import, or I haven't inserted it yet, but I've registered that I need to insert it. So that's what this does. It looks to see if added imports already exists on that path, and if it does, then it returns that alias. This blank is, I'll get to. So the import's already been added. We can just return the one we already did. So that way we don't end up re-inserting the same import multiple times. Now here we go through and try to find an unambiguous name for the import. So that's what this for loop does, right? So first I say unique alias to equal alias. So the first one I'm checking for is the default. So in this case, slices. Then I look for found alias to path to see if it's already been done. And I just found a bug in this. I just discovered a bug as I'm looking at this. Actually, maybe I haven't. No, I did. I did find a bug. So it looks for, it looks to see if that alias already exists. It doesn't matter what it maps to, right? So if I have import slices FMT for some silly reason, it doesn't care that this matches FMT or whatever. Just doesn't match anything. And if so, then we can't use that name. And then it continues by adding an increment. So it first tries slices. If that's not unique, it tries slices 1. If that's not unique, it tries slices 2, and so on and so forth until it finds one that is unique. Then, if the one it found to be unique is the requested one, then it inserts the blank. So that's what this blank was about up here. What was it? Here? So that blank means it was the default. If it wasn't the default, if it was slices 1 or slices 7 or whatever, then it updates the path there. Now the bug is that I don't check this list here. So I can imagine that I could construct a situation. In fact, I think it would be easy. So in this case, yeah, someone did something stupid like this. No, that wouldn't work. I don't know. Anyway, I think there's a bug there. I'll worry about that later. The point is, this function, even though I think it has a bug, is meant to find a unique alias name to be used and register that was going to be added. So now I need to call this function where I do where I create the replacement text, which is right here. And then I'll use this alias here instead of slices. Now, all that work should have made zero difference to the so far to the output of the code. It still does the exact same thing. However, if I change this, let's just be silly here, and let's put println foo. Except I'm going to call it slices.println because I want to be silly here. Import slices font. It didn't do what I expected. I expected it to change the output here to be slices1 instead of slices. That didn't work right. So I may have a bug that I didn't realize. But let me continue. Let me have it. Let me make it import or create the new import, and then I'll worry about solving these bugs. So I want to do one thing at a time. So the next step is I wanted to insert this, right? So I have that also over here. And that is what add imports does. So let me add that logic down here. So the AST parser doesn't like go through the file exactly from top to bottom. It goes depth first. But because the imports are always at the top of the file, I can be certain that they will be processed before, actually more to the point, they can't be nested inside of functions or type definitions. They're always at the top level package. So I know that the imports will be processed before anything that could possibly reference them. So I can do that inspection part, that inspection phase to determine which imports are used and their aliases. I can do that in the same pass as the modification, but I can't insert the requested or the new imports in the same pass because by the time I know which imports to add, I've already finished processing the imports. So I have to do a second pass to add imports. And that's what this does. And I only do it conditionally, only if I have added imports. If the added imports is greater than 0, then I'll call add imports. And let me go up here, and I might just be able to copy this thing again, probably. I'll start with copying it. I think I need to change a little bit. Maybe not. That might be good enough. But let's look through it. So add imports. So now we're on our second pass through the same AST. And we only care about the top level. So this is actually a pretty quick short pass. If we have a node of type AST file, of which there's only ever one per file, it is the file. If we have that node, then we continue. If we don't, we return false, which means stop processing. So this second pass only ever gets called once for one single node, the file node, but that's fine. Within that file node, I know I have a declaration. What is this? I'm creating a declaration I'm creating a new import. Hi, Matt. Welcome from Oregon. Thanks for joining late. So I created a declaration of type import. So that what this is, let me just create a blank notepad. So this effectively represents that. or maybe even just that without the stuff. Like it's an incomplete import statement, right? Then I'm looking for my new import. So I go through the list of added imports, and now I know there's only going to be one here at most. Pardon me. In the other package I was doing this, there could be up to 2, and in some cases maybe more. And I will be generalizing this. So I'm going to keep I'm going to allow it to support the many case, even though I know in this particular package there's only ever one. So it loops through. So it creates a slice of strings, the same as the length of added imports, which will always be 1 in this case, but could be more than that in others. Then it ranges through those, getting the path and alias, and it appends the alias to the list of new imports, right? Then it creates an import spec. So that is, the import spec is this bit. You know, if you have your import statement, that you have alias. Pardon me. I think my voice doesn't like me today. You can think of this alias and path as the import spec. So now we're creating that. So the every import spec has a minimum of path. So that's what this is. We set the path. And then if the alias is not blank, meaning the default, then we add an alias to it. So in the default case, we'll get import slices rather, set the path, and no alias. Then, so we have this declaration up here, that's this. Then we created the specs, we created this part, we insert that into here. It's still not tied to the AST anywhere, it's just this dangling declaration. But then we can create this report. So here, my new text is 2 new lines, followed by the result of printing out that declaration I just defined. And I insert that at the end of file.name, which I believe is where the end of the package statement is. Yeah, the package name. So if our file looks like package foo, and then we have whatever comes after it, I'm telling it to insert 2 blank lines and then my import. Right? Now, this isn't very smart because if there's already an import statement in there, then we end up with multiple imports. So basically I'm adding import slices and whatever's there is already there. It doesn't merge those imports or anything like that. That might be something to add later, but that's not what I'm doing right now. Let's run this. It might work already. It does. It works. So it is successfully inserting that slices import. Let's commit. That was a lot of detour to add one little line of code to our source. All right. There's a lot of refactoring to be done here. There's a lot of duplicate code, but I'm going to worry about that later. Any questions about this so far? I mean, the very, very basic version of this is now working, which is kind of nice. And I could run this on a large code base, so it'll probably generate useful results already. So actually, I should move this new case to my supported cases. Now I'm going to add some more to-dos here because, yeah. So I don't actually know how this will work with the new slices, but you can append a, well, let me do this here. Let's say A is int and B like this. A comma B only equals int 3. I actually need 3 of these. Let's do BC. So I don't actually know how to rewrite this. Pardon me. I'll have to figure that out. So this question in chat, someone came late asking how to summarize the goal. So the goal is I'm writing a static analysis tool and rewriter that will rewrite code that looks like this to this using Go 1.22 added this slices.concat, which can take an arbitrary number of slices and join them together. So it's potentially more efficient, and it's definitely more readable, I think, than using multiple copies of append. So that's what we're trying to do, is to rewrite that for us. Now, what I don't know, so we've proven that it works already for this case. We're joining 3 slices together. We can simplify to this. The next question is, well, let me just write the code here. So I've written this to do here, but I think it'll be easier if I write the code here. So we have, let's say we have A, B, C equals 1, 2, 3. So 3 integers. And we have slice S1. So we want to do this append. I'm going to simplify this too. It shouldn't matter now that we're not looking for. Now the thing is, I don't actually think this, I don't know how to rewrite this to use slices.append. So we're going to experiment and figure that out. Let's go over to our browser here. Let's copy that code. I'll just copy the whole thing here. I found a syntax error for me. Let's fix that. Right. C declared and not used. Oh, that should be C there. Yeah. So the thing is, so actually, this particular case is better done as an append. It should just look like this. Because those are individual. Those are integers, not slices of integers, each argument there, right? So the question I need to figure out is, what do I want to do in my case? Because I'm pretty sure my thing does it wrong right now. Let's see what it does, but I'm sure it doesn't handle that right. Still that syntax error. I need to change this to C. So that there's 2 problems here. One is that it only handles 2 levels of append. We need to make that support arbitrary depths of append. Let me just get rid of that problem for right now, because that's not what I'm concerned about. Let me get rid of this C thing. We'll just do 2 levels. Well, let me add that to the to-do list, right? All right, so I won't forget about that. All right, so the problem I'm concerned about here is that this won't work for slices.concat. I don't think. I'm pretty sure it won't. Yeah, because slices.concat requires slice arguments, whereas append requires individual element arguments. That's why we saw in the slices case, we saw this ... So what I'm trying to think of what I want to do. So basically, I want to not rewrite it in this case. In this case, it should remain as it is. I might want to rewrite it to use a single append, but that's not the point for this So I actually want this one to stay the same. How do I detect that? This is like the negative case of what I want to solve, right? All right, so let me think about this. One way would be to see if this is variadic. That would solve this case. If this is variadic, then transform it. If it's not variadic, don't. Except that wouldn't solve the case. Actually, that might be good enough. Might be. I'm trying to think if there's ever a way you could pass a slice there that's not variadic, but I don't think you can. It has to be variadic if it's a slice. All right, let's go for that. I think I had that example up here. Let me delete the stuff I don't care about. I want to see what that variadic argument looks like, that S2. How is that indicated to be variadic? Ellipse is right there. All right, so we need to check for that thing. Looking for inspect. Here we go. After I fix this, I'm going to refactor a little bit because it's so annoying. Actually, let me delete this debug thing. I don't need that anymore. I've already solved that problem. All right, so inspect. This is all about import stuff. I don't care about that right now. Put a new one here just for the moment. I'll move that to a new function in a minute. But right now I'm checking, this is a part of RHS. Part of a call expression, okay. Okay, so ellipse is the location or the position of the ellipse, or no pause if there isn't one. So I want to check for that. And that would be in in either one, I guess, right? So these could be mixed together. I could have, just for example, I could have append S1, S2, ... and then B or something, right? You know, where it's a single integer instead of a slice. For now, I'm going to only worry about them all being that, I guess. So how do I do that? Here's the inner call. Let's start with the outer call. It's right here. Ellipsis. Let's do it. That should be or actually. So there we go. That should be enough to fix it actually already. Except I didn't update my code quite right, but it did solve that particular problem. So that second one's no longer being rewritten. What? Yeah, all right. So the second one's no longer being rewritten because the first call expression, this one, does not have a variadic function. I'm going to do the same check, though, for the inner one. It should be right here. Nope, not here. Right here. And this should be inner call. All right. All right, let me update that to-do list here. Actually, well, I guess I could leave it there. I don't know. It's not a thing I do. It's a thing I don't do. I'm going to just delete that. All right, I think we're good there. Let's do that rewrite I was talking about, or refactor. I want to move that import function out. So let's create a function called, just call it inspect imports. And I'm not going to have this return anything. I just want it to do this stuff in line and then continue on its way. So this return false goes away. And then here I do inspect imports node. All right, let's verify that everything still works. Good. Well, that didn't really simplify anything. It just moved it away. So now it's easier to simplify. So let's do else return. And now I can have my IDE switch this around for me. Factor invert if condition. Now it does an early return. Oh, but I have to move that out of the if block. So the scope is good. So rather than having a lot of indentation, I'm going to optimize for longer but easier to read code. At least that's the intention. I'm going to do the same thing here. Else return. And then invert this. And same thing here. And there we go. It's a longer function now, but I think it's easier to read. I can just read it straight down the thing with early returns. I think it's a lot easier to read. Alrighty. About half an hour left. I think my next goal is going to be to tackle the arbitrary number of appends. So I'm just going to add more of these. Append. I'll just re-add the same slices together. Why not? I don't actually care about the results of the slice of the append. I just care that the syntax is handled properly. So this should be rewritten to slices.concat. One is 2, S3, S1, S3, and that should be it. It's not rewritten that way, obviously. So I have these appends here because it only checks 2 levels. So this will be a good test to figure out how to make that a little bit more robust. And I don't know the answer to that yet. Let me think about how this will work. I mean, I'm going to need to extract a bunch of this logic to its own function. And then it'll probably be recursive. I just realized, I think there's also the possibility to have appends in the second argument. So let me add that to my to-do list. Could have something like append S1, append S2, and I want that to be rewritten also. And that would have to be done. So I really need to check if either argument to append is append, not just the first one, right? Yeah. And then if it is, I want to sort of gather up their arguments All right, let me think about this a little bit more. Maybe I should start with that case, actually. That might be simpler to solve. Let's start with that. Let's just switch this around to be S1, comma, append S2, S3. Let's switch this, because it's logically the same thing as the other one. But I don't think we handle it the same way. So let's solve that problem first. I think that will then make the recursive thing easier to solve. Yeah, that's failing as expected. All right, and then actually we could have the more complicated case yet. We could have append being called twice, append S1, S4. We could have both being appends, right? We'll handle that next. We'll get there. I want to make a note so I don't forget. All right, where's this append happening? Here we go. So here's where we check if the first argument is append. Okay, I recall earlier not ChatGPT, Copilot wanted to check that I only had 2 arguments, and I said I don't care about that. I actually do care about that. So that's one way to get rid of. Well, actually, I don't know if I care about that. I mean, I think it's a duplicate of checking for this ellipse. I'll get rid of it for now. But what I want to check here is, so what I want here is some sort of recursive function. I think I already want that, because I want to be able to call it on the first argument and on the second argument. And I want this function. What do I want it to do? Get append args. That's not a good name, but I'm going to start with that. And I want to pass it the call expression, and I want it to return. I don't want this. I want it to return a slice of expressions, I think. Let me see what that, I think that's what I need. Yeah, it's a slice of expressions. And, okay. And I think I want a Boolean. Returns the arguments to the append function call if call is equal to append. If call is not a call to append, the second value will be false. So let's call this get append slice args. A little more specific. Returns the slice arguments to append if call is an append call and true, otherwise returns null and false. I think that explains what I want. So I'm going to copy. Let's see here. Yeah, I think that's sufficient. Now I just need to implement it. I want this to recall. It's not quite what I want here. Okay, if it's not 2, then return false. That's fine. That's fine. Do a quick check. If call.fun.name. Is that right? Yeah, does not equal append. Return nil false. That's not right. That needs to be an ident. Okay. Call ident. There we go. Okay, so now I have, up to now, I have determined that it is a call to append, has 2 arguments. That's what I have. Okay. What's next? I'm not going to do this ellipse yet because that's not quite the right approach yet, I don't think. So now it's a recursive. I'm going to do if. Is that true? Maybe I do want to do that ellipse thing. No, so first I want to do args equals, I don't care about the length right now. I'll figure that out later. If the first argument is a call to append, no, is not. It's not a call to append, add it to args. Now, this is easier done the other way around. So I want, I want args colon okay equals, I'm going to be recursive already, get append slice args. But now I call it on, no, that's, args str. Let's just do that. Now, if in your call, okay, so now my first argument 0, is a call expression. Then I'll go ahead and pass it to Is that right? Is that right? If okay, args equals append inner args. Otherwise, args equals the thing is, if it's in a call to append, I want to recursively call this same function. Anything else, I want to just add it directly. Okay, so I have a different solution to this. This needs to change a little bit. Returns. Sorry. This needs to be AST.expr. There. So by moving that assertion into this function, it simplified the way this should work, I think. Yeah, now I can just pass that in directly. Yeah, okay. So if it is a call to append, then it will recursively extract those arguments, pass them here. If it's not, then I just pass that argument directly. Okay. Now I want to do the same thing for the second argument. Is it that simple? I don't think it's that simple. It might be. Second args. No, it's definitely not that simple. So let's call this first args. And then I'm sure this is more complicated than it has to be, but I can simplify later. Second args. Okay, good. In this case, I actually want to return nil false, I think. I'm not sure if this is even close to right. My brain is mush now. Okay, so let me walk through this a little bit. So the first time I get to a pen, we pass it here. It's going to do a type assertion that it's a call expression. It will succeed. It has two arguments. It succeeds. The first one, the func has an ident that will succeed. It's called a pen that will succeed. And then we look at the first argument. We pass that first argument to this function recursively. It will succeed. Here it will fail, so we'll do this and return the first argument, which is S1. Well, we'll append the first argument, which is S1. Then it comes here. And I need to do the same thing here. Yeah, I did this. So okay. Except that in the case of the second argument, I need to do that ellipse check. So the ellipse check matters to the whole thing. Yeah, so I need to do that. Is it right here? Where did I do that before? So on the ident thing. Call.fun. I can go right here. And then I don't need this. So if I get to an append that isn't appending a full slice, meaning there's indicated by the fact that there's no ellipse, then I treat it as its own unit, right? I can't dig into it further. I think this is right now then. So let's start using this. Here I want args, okay. Probably want this to return. No, maybe not. I think that's what I want there. So I can kind of delete all of this, I think. If not, okay, then return true. Args goes here. Why isn't it like that? Oh, because it's not a function call. All right, no. Well, this would just be directly here. I need it in a thing. Undefined call. Yeah, okay, because it's called node now. Oops. A simpler way is just to make this support a complete .no, and that'll be simpler than doing two type assertions. There we go. Let's see if I broke anything. I didn't. I actually fixed it. It's kind of amazing. I did all that without making things worse. Okay, and I think I solved the recursive problem at the same time. Well, let's go ahead and make a commit here. Adopted my to-do. I want to move this case to the supported list, to the done list. Oh, I don't need that minus thing there. All right, now let's try the more complicated case. In fact, let's mix these together. S1, append, S2, append, S3, S2, dot, 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 dot. You think it'll work? This should become slices.concat, S1, S2, S3, and S2. Whoops, S2. Will it work? It did work. I just had an extra new line in there somewhere. Yeah, so I solved a recursive problem at the same time. That's handy. Now I want to add another case here that mixes the both kinds of appends. So here I have S3, 1, 2, 3, dot, 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 dot. And I'm not exactly sure what this should look like in the end, but let's see if we can come up with a reasonable answer and then see if it matches what actually happens. So this should do slices.concat S1, and then I think it'll do that. This append, oh, this append, this middle append isn't complete, is it? Let's add S2 there, both places. S2. So actually, this one can be eliminated. And this one should become, I think this is what it should become. This one should remain because the internal argument, it doesn't use the ellipse because these are individual integers, not slices. So this should be seen as its own standalone slice. I think that's what we'll get. What we should get. Let's see if we actually get it. We do. Great. So let's come over here and I've solved arbitrary depth. Is that the same as this? I think so. So I've solved all those cases. So what I probably want to add now is, well, I think the only thing I want to add now is to do this for Go 122, which I'm not going to do now. I only have 2 minutes left. And it's mostly going to be copying and pasting anyway. And then I probably want to add another rule that shortens this sort of stuff. But since that's not dependent on Go 122, it should be a separate rule because I want to be able to run that on all versions of Go and not just Go 122. So I think I'm going to declare success. I think we've got it. Let's run it on some real code, why don't we? So I have a code base for a client. I think I'm trying to think if I can even put it on my screen. I don't think there's any trade secrets on there. this rule again. Okay. Just see how many things it does, and if it crashes or does anything stupid. Quite frequently on some of these rules, I find that running it on a real code base causes a crash because there was some sort of condition I hadn't considered or whatever. Okay, it didn't crash. That's nice. So I had an interesting output there. Let me zoom in a little bit. It's not working quite right. It says added new imports, and it's saying nothing. So there's at least a bug in the output. I don't know if it's making invalid code. Let's have a look. So it did import slices correctly. So the invalid code concern doesn't seem to be a problem. And then here, it looks like it did a good job. It converted an append to slices. Now this is a case I hadn't actually considered that this was what I wanted. I wasn't trying to replace a single append, but it did, and maybe that's okay. It's probably fine. Oh, actually, I just realized there is a case I didn't cover yet, which we're not going to have time for today, and that is the multiple. Maybe that's what I deleted actually here. No, it's not. Oh, yeah, it is. What I meant was this case, where we have multiple appends on separate lines. Append equals append equals append equals, where we're modifying the same variable each time. That's the case I really want to solve. Well, I won't have time for that today, obviously. Let's just look through this a little bit more, see if anything else broke. So yeah, the fact that these import statements are created as a separate block of imports is kind of annoying. The way I solve that, you can just run a linter or go imports or something, and that'll clean that up for you. And that's fine for right now, since this is kind of an experimental toy. Once I have this more mature, I want it to do it correctly, and I don't know how to do that correctly yet. And also, it depends on which import tool you're using. So I have to give that some thought, but let's just do some more spot checking on here. Okay, so here's a great example of the thing I actually want to solve. These three import statements, they're all modifying the same variable. These should become a single slices.concat. So I want this to become imports equals slices.concat, imports comma blah, comma prop blah, comma prop template blah. So that's the actual case I want to solve, really. And it's not doing that yet. Even so, what it's doing is probably worthwhile, because slices.concat has some performance improvements. It may actually even be faster than this in some cases. I'm not 100% sure. Need to do some benchmarking or some reading to determine that. I'm certain that it's faster when you have, or I'm certain that it has the potential to be faster when you have more than two. When you're doing three or more together, then it can definitely be faster because it can reduce the number of allocations. But for the simple case, I'm not sure if it actually is faster. And it's up in the air in my mind whether it's more readable. Let me know what you think. Do you think it's more readable to use append or slices.concat? Anyway, I think I'm about done with this. There's one more comment on the chat that I'll try to address. So far, it looks good to me. This is an interesting case where it looks like it's removing an item from a slice, and append feels more idiomatic to me for this sort of thing than slices.concat. But yeah, no, I'll have to think about this. If I don't want to rewrite all of these cases where there's only two, let me just do that actually. Reset this. Go back to my code here. Args. Where can I call this from? Here. What if I just early return if length of args is less than 3? I think that'll still catch my test cases. Yeah. Let me see what that does in this code base, if it actually does anything at all. Because then it's going to only do append within append. Now, it's still caught several. Let's see if they're interesting. So here we had append and append, exactly what we're looking for. And now it slices concat with 3 arguments. So yeah, that's a good example. And it's shorter. It's not a lot shorter, but it's a little bit shorter and very likely more performant. Here's another example. Append, blah, 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 3 arguments. So yeah, that is useful at least. That catches the pattern I was looking for when it's done as a single statement. Yeah, that's cool. Here we even simplify, turn 2 lines into 1. Yeah, I like that. So I have to decide whether or not replacing append with slices in the general case makes sense. And that probably depends on benchmarks. But yeah, this is a win for sure. Even if I don't do it for the general case, this is a win. So I'm happy with that, the result. So the question, the last question I'll answer, looks like you're using Debian and Plasma for your dev workstation. How do you like it? I've been using Debian since 1998 or something like that. I was a Debian developer for many years. It's just been my default. I've always used Debian, and switching at this point would be like learning how to drive on the other side of the road. It's just a pain in the ass for no reason. So I have no intention to. I'm happy with it. Does that mean it's better than something else? No. It means I'm comfortable with it. So I don't know if that helps, but that's my answer. That's why I use Debian. Thanks everybody for joining today. I hope you learned something. I learned a bunch of things. I'll be doing this again probably next week. I try to do this every week unless I have a holiday or something coming up. Oh, I forgot to mention, I should have mentioned this at the top of the hour. On Thursday, I'm going to be doing a special live stream with Dennis and Adrian. They were on here 3 or 4 weeks ago. We did pair programming. I'm going to join them on their channel on Thursday. I'll announce that on my mailing list and on LinkedIn and everywhere else. So if you're not on my mailing list, go over to boldlygo.tech/daily, sign up there so you don't miss those announcements. And so you get my daily Go tips. Anyway, thanks. I know there's not a lot of people stuck around this late. Thanks for sticking around. Thanks for joining me, and hope to see you all next week. Cheers.